Okay, I'm showing 7 o'clock, so we'll get started. Good morning. My name is Bob Battle, and I'm an Extension Field Crops Educator in the Thumb. Specialist this morning is Kurt Steinke. Kurt is a Soil Fertility Specialist at MSU. He'll be talking to us about early season soil fertility. Just want to let everyone know that if you have any questions during the presentation, there's a chat function screen. Feel free to type your question in there. We'll turn things over to Kurt.
Thanks, Bob. All right, I'd like to welcome everybody here this morning. We're going to go over a couple of quick fertility items. Given the recent weather we've had, we've probably had a few concerns. You know, the question that I tend to get this time of year, and I've gotten a lot already this year, is am I already too late with my nitrogen? Given that today is May 9th, some of us think we're quite behind. You know, the answer is absolutely not. When you look at where we are, you know, some delays that we've had so far probably are a good thing. Many of us probably still have our seed still sitting in the shop, probably in the bag. So we're not the only ones. Some of the I states are pretty far behind also. So, you know, if you try to look at this as a glass half full scenario, you know, we may have a little less risk of N loss since we've missed some of these wet conditions early in the season. So we might miss some of that denitrification, some of those leaching N losses that we normally see with some of our early N applications. We've all seen some pooling standing water out and about through many of the fields that we've seen. So not necessarily a bad thing to be in the position that we're at. And the other thing we need to remember is, you know, when you look at N uptake by growth stage, we see very, very little N uptake early in the season. So you can look at some of the icons I have here. Between emergence and V2, you're looking at about 3% of your total N uptaken in the corn crop. V2 to V6, about 7%. It's not till we get to that V6, V10 scenario that we get about 18% of our N uptaken during that time. So as you go along there, you can see that V10 to V14, about a third of our N gets taken up. But one thing to remember is we want to have our N in the ground, solubilized, and that corn root, especially being able to uptake that N at that time, not necessarily apply the bulk of our N at that time. The other thing you'll notice with the little graph that I have displayed here is, you know, we can look at these uptake amounts by growth stage, but the big thing is a lot of this would be driven by growing degree days also, and that's one thing we really haven't accumulated much yet this spring, so we're not necessarily that far behind. And if you look at the long-term forecast, the GDDs might be a little slow accumulating here over the next couple of weeks. The other thing to remember here is that usually about 30 to 50 units of N near planting time or at planting time, whether it's pre-plant incorporated, pre-applied, or even something like a 2x2, usually perform quite similar, in many cases better than everything applied pre-plant. So just because you don't have any N or all of your N out yet isn't necessarily a bad thing. The next question that usually comes up is starter or no starter. Should I or should I not use starter fertilizer? So to set the table here a little bit, when you look at what starter fertilizer is, most of us probably remember that it's fertilizer applied near the seed at planting time. There's a couple advantages to using a starter fertilizer. One being stimulate early plant growth. Okay, we've seen this quite often. If you look at the photo here to the right, that's actually a sugar beet crop. On the right hand of that photo, those sugar beets got 40 units of N in a 2x2. On the left side of this photo, those sugar beets did not receive any N in a 2x2. So you can see, given whether it's optimal or suboptimal conditions, these plants sitting over on the right typically will always stay ahead of those plants sitting on the left, regardless of management from this point going forward. So it does stimulate early plant growth. That does not necessarily mean it's going to result in a yield response, however. Because we do see some of this early plant growth, it can aid in weed control. with row closure earlier with some shading of the row. Can also alter some tassel and pollination timing. So typically starter may move up or cause that plant to hit the R stages a couple days sooner and then pollinate a little bit sooner. That could be a benefit. That could be a negative. That often depends on soil moisture at both tassel and pollination timing. We know band placement tends to be very efficient. Why? Because you place that fertilizer where it has a very high probability of root contact as compared to some of our broadcast applications. The other items to think about, micronutrients. If you know you are going to need a micronutrient, perhaps it's due to a micronutrient deficiency that you saw in that area of the field last year, or if you know you need phosphorus, placing both those phosphorus and micros in a band at planting time does minimize fixation and can maximize plant uptake. The other idea, again, with nitrogen applied in a starter is it can improve the uptake of other nutrients. Nitrogen can stimulate both root growth and above ground growth. So the bigger root mass you have, you can stimulate the uptake of P, K, magnesium, manganese, etc. on down the line. The other item to consider with regards to starter would be the last one listed there, and that'd be trying to ensure against the unknown. And what that unknown is probably what most of us are going to be experiencing here most of today, is rainfall. And we don't know what type of rainfall variability we will have this year. You can see the numbers listed there. For Lansing, April 2019, we had about 2.9 inches. Very similar to 2016. That's good news for our wheat crop. But you can see May and June, we just don't know what is going to happen. We have an equal chance, if you look over the last 12 or 13 years, of having excessively dry conditions, excessively wet, or a fairly normal May and or June rainfall conditions. So that's one thing we don't know, and we can kind of ensure against some of that by setting up that plant to do well mid-season. Now, are there disadvantages to using starter? Absolutely. When you start thinking about a 2x2 application or a subsurface banded application, we do bring more soil to the surface. So if you are in a higher clay type soil, many of what we tend to experience up towards the thumb region, such as our sugar beet region, we do tend to bring more soil to the surface, which can make planting conditions a little bit tougher for that seed to soil contact. The other thing is with that starter, we might have to delay planting a couple days due to that soil moisture. Oftentimes, when it gets into that sticky type of scenario, we tend to have to wait a couple days for the just beneath the soil surface to dry out. And so it might delay planting from anywhere from 2 to 4 days as compared to not using a starter application, because we don't want to get those nozzles plugged. And another disadvantage will probably be speed. It will slow you down. All right, that's pretty well known. But again, you want to use your nutrients efficiently. The last item here is, what is your side dress preference? Is it early or is it late? Because this may also dictate whether you use a starter or choose not to use a starter fertilizer. Here's a picture looking at a V11 Sidedress Timing from a couple years back. Picture on the left, you can see had about 7 units of N in furrow with 133 units at V4 Sidedress. Picture on the right had 7 units in furrow with 133 units of N at V11 Sidedress. So notice at the bottom of the picture on the right where you see the red arrow, you can already see some leaf firing occurring, which is not what we want to see in mid to late June on a growing corn crop. So if you're going to go with a later Sidedress application, a late vegetative, closer to an R stage Sidedress application timing, you may want to go with a starter fertilizer to try to get that crop to that point in time. You have to give that crop enough fuel to get to that Sidedress timing, especially if you go with a later Sidedress application. The last thing here is you want to set that plant up to capitalize on June or July growing conditions. What do I mean by that? Here's a picture from 2018, some corn grain yield observations. 2 cobs on the left, you see had about 145 units of N. side-dressed at V4. 2 cobs on the right had 40 units of N in a 2x2 with 105 units of N at V4. So same total N rate. What was the difference? Cobs on the right that you can see here had that 40 units of N in a 2x2 at starter time, which resulted in, we're looking there at about a 25 to 30 bushel difference. Why? If you remember from last year, June and July were quite dry, especially in south central Michigan. We had about 2 inches of rain total for the months of June and July. So in about an 9 week period, we had 2 inches total. When you look at that same type of timing, but different side dress timing, 2 cobs on the left in this photo had about 145 units of N applied at V12. 2 cobs on the right had that starter, that 40 units of N in a 2x2 with those 105 units also at V12. And there again, you're looking at close to a 25 bushel difference just by using that starter fertilizer application. Again, those dry conditions in June and July really hampered the development of that corn crop. So where we had that starter fertilizer, that plant was set up to do well regardless of that side dress application timing. Now, it may not always turn out that way. There's a big difference between an early season drought, a mid-season drought, and a late season drought. So that's also something to consider. So when you look at starter N implications, big thing with corn is we have to satisfy those early corn N requirements. We know that yield expression is influenced early. We have to have sufficient N until that side dress timing. Whatever side dress timing you choose, you have to give that crop enough fuel or enough gas in the tank to get to that side dress timing. We know that 2x2 applied N or subsurface applied N at planting has continued to offer fairly consistent grain yield response. It offers that plant that start right capacity to capitalize on those mid and late season environmental conditions. But again, I'll emphasize a positive grain yield response will not always occur. It's going to depend on that precipitation, especially that June and July period. We know 40 units of N in a 2x2 as starter on corn is not sufficient to delay your side dress to V11. So if you want to go with the later vegetative or closer to our stage side dress application timing, you need a rate above that 40 units of N in that 2x2. I'm going to change gears here quickly a little bit. We're talking a little bit about phosphorus. You know, I kind of feel like an old fuddy-duddy here putting don't guess soil test up there. That goes back to the mid to late 80s, early 90s, but it rings true more now than ever. Should you or should you not use phosphorus in your starter fertilizer? Get a soil test to determine whether you need to apply or not. So we wrapped up some on-farm field trials over the last 3 years, looking at soil test phosphorus. This graph looks at soil test phosphorus versus your relative corn grain yield. So again, your soil test phosphorus is along that bottom axis. Your relative grain yield is along that y-axis, along the left-hand margin of that graph. And what we found is when we mapped this out, our critical value when you fit the curve ended up to be about 16 parts per million. Okay, very close to the 15 parts per million that we've always used. So no, things have not changed dramatically, even if when you look at newer germplasm or newer cultivars, newer hybrids that are out there in combination with newer cultural practices, etc. Soils don't change very quickly. So you want to know what those critical values are. And so this is always a good reminder to look at should you or should you not apply phosphorus to your corn, soybean, and wheat. Remember, your Bray P1 critical levels for corn, soybean, and wheat will be 15, 15, and 25 parts per million. So what that critical level represents is about 95 to 97% of your yield goal. All right. So outside of that, you're only looking at about anywhere from 3 to 5% of your yield variation. So if you're below that 15, 15, or 25 for your corn, soybean, and wheat, you're much more likely to see a positive response. It's not necessarily guaranteed. And if you're above, how much above are you? If you're in this 15 to 30 range for corn and soybean, that sufficiency zone, that adequate zone, or that maintenance range, you might want to apply maintenance application. If you're in this 30 to 40 parts per million drawdown zone for corn and soybean, it'd be 25 to 40 parts per million for wheat, or 40 to 50 for wheat. You might want to apply about 1/2 a crop removal. And with corn and soybean, when you get above 40 parts per million, which many of our fields are, you're really not likely to see a yield response to a phos application. You might see a plant response, not necessarily a yield response. So again, when you talk about phos, you want to look at that soil test. You want to use the correct soil test. So if you're in a higher pH scenario, I'd say probably 7.4, 7.5 and above, and tend to have a high calcium content. Make sure you go with perhaps the Olsen analysis, not necessarily the Bray or the Malick. You want to look at that report. Okay, I think the average is about 50% or under of our growers actually look at their soil test report. So look at that report, look at what it says, understand and interpret that report, know who is interpreting that report. Some labs, some consultants have different interpretations, which may not necessarily equate into whether you should or should not apply the phosphorus fertilizer. And we also know that there's no relationship between soil test, phos, and grain yield. We haven't seen that in Michigan, we haven't seen that in Ohio, and we haven't seen that in Indiana. Another good point is know your realistic yield potential. Okay, remember your yield potential, your realistic yield potential should be achievable in 1 out of every 2 years. If you haven't achieved that, or if your yield potential is set too high, you will always over apply nutrients, and that's something we do not want to do. Your P applications cannot be based simply on uptake and removal. They have to be based on that soil test and that likelihood of seeing a response. So at the end of the day, remember that phosphorus is still a critical part of a balanced crop nutrition program, but we really want to take a look at that soil test and whether we should or should not be applying phosphorus to our production ag acres. The last thing we're going to hit on here is sulfur. So we know we have less sulfur today than previous years. It's not an area I would like to see eliminated or that you should eliminate from your crop nutrition program. All right, we tend to see S deficiencies more now than we ever have. But remember, sulfur is not nitrogen. We do not need sulfur in the same quantities that we need nitrogen. So when you start looking at corn, we're probably in this 20 to 40 pounds to the acre wheelhouse. Soybeans, probably 15 to 25. Wheat, probably in about that 20 to 30 pounds of sulfur to the acre range. We are tending to see a few more non-responsive sites. That's simply due to more continuous sulfur applications. So take a look at your starter program. Should you not apply sulfur? Again, rotations and maturity lengths will matter. We tend to see less likely of a response in soybean. They have seen more positive responses to sulfur on soybean as you move south through Indiana especially. But we tend to see a little bit more of a diverse crop rotation in Michigan than we do some of the states south of our border. And some of the crops in our rotation tend to be a little bit more S responsive. So if you apply sulfur to your corn and or wheat crops, you may not necessarily see a response in that soybean crop. And we also tend to see a little bit shorter maturity lengths or maturity groups in Michigan with regard to our soybean. And that could be another reason we do not see responses as frequently in soybean as we do in corn and wheat. The other thing to think about if you're considering S in your starter program is, do you want early S or do you want late S to stick around for that plant, or do you want both? So as we plant earlier in springtime, we tend to encounter S deficient conditions for a longer period of time. At the same time, when you start looking at late season uptake, whether it's in corn and soybean, predominantly here looking at after R4 or after R5, we know a lot of that late season S comes from the soil. So that may dictate what type of S source you use. So there's multiple S sources out there nowadays. Some of those have all soluble sulfate sulfur. Some have a combination, maybe half sulfate sulfur, which is immediately available, and half elemental S that can become available as time goes on. So that's something to think about, whether you want early availability or late or both. A couple resources to consider as we wrap up here. Soil.msu.edu is our website for the soil fertility program. Lots of good information on there. We have a couple videos posted on there that'll may offer some insight, especially with corn, on how to use certain models to predict your corn N rates, early and late sidedress timings in corn, some early season corn S strategies. We also have a couple articles on there that were posted more recently looking at pre-plant in-season end combinations, corn end guidelines and focusing on the right rate, strategies for corn sidedress nitrogen placement, and starting right to finish well, how to get that corn plant off to a good start. So with that, I will wrap up. I know there's a link listed on that slide at the top if you want to go out and fill out the online evaluation survey. But other than that, I will wrap up and appreciate your time this morning. Thank you.